Hey guys, in this lesson we would understand the basics of acid-base equilibrium. Let's first understand what is meant by acids and bases. We would be following two theories to understand it. The two theories that define acids and bases are Arrhenius theory. Name comes from the name of the scientist who's given this theory. And the second is Bronsted-Lowry theory. Arrhenius theory said that acid is any substance that loses or gives off H positive ion, and base is a substance that loses OH negative ions. Therefore, example of an acid is, let's say HCl, because it contains H, so when it will be broken down into ions, or when we dissolve it into an aqueous solution, it gives us H positive and Cl negative. So it is releasing H positive ion. Similarly, if we take an example of a base, NaOH is an example of a base. When this breaks up in aqueous solution, or if this is dissolved in water, it gives us Na positive and OH negative. Since this one is giving us OH negative, this is called a base, and this one is giving us H positive, so this is called an acid. And these definitions are given by the person called Arrhenius. That's why it's called Arrhenius theory of acids and bases. Or we can also say this is Arrhenius' definition of acids and bases. Arrhenius theory is not wrong because we have bases that lose OH negative ions and acids lose H positive ions. However, there are certain bases that do not contain OH negative ion. Example is ammonia, NH3. It's a very common base, but it contains no OH negative ion. So ammonia does not fit under the definition of Arrhenius theory. That's why Bronsted-Lowry came up with another theory, and they said acid is anything that loses H positive ion. So this is correct, same as Arrhenius. Whereas base would have another definition, and that means base is anything that gains H positive ion. So all those bases that contain OH, for example NaOH contains OH, this can fit under the definition of Arrhenius theory. However, all the bases that do not contain OH, they would fit under the definition of Bronsted-Lowry theory. Let's take an example for this. Ammonia, which is NH3. When NH3 is going to be dissolved in water, what it does is it would take H positive from water and would become NH4 positive, leaving OH negative from water. Since acids are anything that lose H positive ion and NH3 is not losing H positive ion, it is gaining H positive ion, it fits under the definition of bases. Also, we know anything that has a pH less than 7 is an acid. Anything that has pH greater than 7 is a base. This you know from the previous grades. NH3 has pH greater than 7, so we know that this is a base. And how do we prove this is a base? Chemically, that is with the help of this reaction. When NH3 reacts with water, it takes H positive ion from water and becomes NH4 positive. Therefore, bases are those substances that gain H positive ion. Now, there are certain substances that behave as both acids and bases, means they fall under the definition of both acids and bases. Those substances have a special name called amphoteric. Example is water. It's a very common amphoteric substance. So when water comes with an acid, we know HCl is a very common acid. This is hydrochloric acid. When reacts with water, because HCl is a strong acid, it will not let water act as an acid. Therefore, HCl is going to lose H positive ion and is going to give it to what? The only other substance that is present is water with it. So HCl would lose H positive ion that is going to be gained by water. Therefore, HCl becomes Cl negative and water becomes H3O positive because H2 is going to get another H that will give us 3H, and then a positive charge will stay on top. So this is H3O positive. Therefore, in this case, water is gaining H positive ion, and the definition according to Bronsted-Lowry is any substance that gains H positive ion is called a base. So water will be called a base. And if water comes with ammonia, then ammonia takes H positive ion from water. Therefore, ammonia is going to be called a base. and in that case water is going to be called an acid. Ammonia would give us NH4 positive because H3 and then another H positive gets added to NH3, gives us NH4 positive, and here we are left with OH negative. How is this being formed from water? Is because water is H2O and it is splitting up into H positive and OH negative. This H positive is gained by ammonia to become NH4 positive and OH negative stays as is. Therefore, in this case, water behaves as an acid. So water in certain cases behave as an acid and in certain cases behave as a base. Therefore, water comes under a definition of amphoteric substance. Now here we need to understand one more thing, that is, if HCl is called acid, it forms Cl negative. What is Cl negative going to be called? Always remember, if a substance is an acid, then after releasing H positive ion, that substance is going to form its conjugate pair, and the name is conjugate base. Similarly, a substance that is a base is going to give us a conjugate acid. In this case as well, this was a base initially. Now it has given us NH4 positive. So what is this NH4 positive going to be called? Is a conjugate acid. Acid is going to form a substance that's called a conjugate base. Therefore, we have developed a conjugate acid-base pair. That is, if we have HCl, it becomes Cl negative, where this is called an acid and this is called a conjugate base. Similarly, if we have water and it becomes H3O positive, then here the water is called base and this is called its conjugate acid. Let's say if you were given something like this and you were supposed to identify what is the conjugate acid and what is the base, or identify the conjugate acid base pair, then how would you decide which one is a conjugate acid or which one is a base or which one is a conjugate base and which one is an acid? So let's do an example for that. Let's say if we have H2SO4 and HSO4 negative given to us, how do we decide which one is an acid and which one is a conjugate base, or vice versa? Then we look at the number of hydrogen ions contained. Now this one has 2 hydrogen, this one has 1 hydrogen. That means this one has lost H positive to form this. So the substance that loses H positive is going to be called an acid, and what it forms is going to be called a conjugate base. Let's take up another example. If we had CH3CO negative giving us CH3COOH, again we have to look for H positive ion. We see here this one is short of H positive and this one has an extra H. That means the one that would have an extra H, that is going to be an acid, and the one that is short of H is going to be a base. However, the reaction is read from left to right. So in this case, in order to form CH3COOH, CH3CO negative has gained H positive ion. Therefore, this is called a base and this is called a conjugate acid. And this is how we identify, given a conjugate acid base pair, which one is a base and which one is its conjugate, or vice versa. So these are the questions where we are given pairs. What if we're given an equation? Let's say we're given an equation. H2S plus NH3 gives us NH4 positive plus HS negative. In this case, we would see who's giving us what. So we got H2S. Definitely H2S is going to give us HS negative. So let's compare H2S with HS negative. Now, in order for H2S to form HS negative, it must have lost H positive ion. Because H2S has lost, so we would call H2S as an acid and we would call HS negative as its conjugate base. Similarly, NH3 has given us NH4 positive and NH3 has gained H positive in order to form NH4 positive. Any substance that gains H positive is a base, therefore NH3 is a base and NH4 positive is its conjugate acid. And this is how we identify conjugate acid-base pairs when it comes to questions in the form of equations.